We'll get to them after, or you can unmute yourself at the end and we can have more of a conversation. But we'll get to some questions in the end. Slides and recording will be distributed around the end of the week if you need that, and it will also be posted to our archive site on our website. Feel free to check that out. And also, our LinkedIn is newer this year, so if you want to give us a follow on our LinkedIn page, CA Gas Tech, that would be lovely. But otherwise, I'm going to hand it to our speaker, Anushka, right now, and we'll get started.
Great. Thank you so much, Kate. Good afternoon, everyone. My name is Anushka Cholakath, and I'm one of the engineers at ICF working on the Gas Emerging Technologies program. So today I will be presenting the findings of a market study that we conducted earlier this year on emerging ultra-low NOx burner technologies. So for the agenda today, I will quickly go over the project objectives, the interviews and findings from that. We'll talk a little bit about hydrogen blending in ultra-low NOx burners and wrap up with the conclusion and project recommendations. As Kate had mentioned, we will have time at the very end for questions, so feel free to save your questions for later or drop them in the chat. All right, so for the project objectives, the main goal of the study was to just gather updated market data on emerging ultra-low NOx burner technologies that have been commercialized or are close to hitting the market. Before we go forward, we have defined ultra-low NOx at emissions of 9 parts per million of nitrous oxides or less, based on the different air quality district rules here in California. The requirements vary a lot based on the application and the specifics. But again, for this study, we stuck to around 9 parts per million or less. Another objective of the study was to conduct a literature review to better understand the ultra-low NOx burner technologies, as well as identify manufacturers and subject matter experts to interview. Based on what we found from the literature review, we then developed a list of subject matter experts, which consisted of burner manufacturers and researchers from different research institutions to learn more about the current technology offerings. And finally, the last objective was the data collection step, which consisted of different interviews and site visits. And I will go into more details on this in the next several slides. So for the interview questions, we had a standard list of questions to help facilitate these interviews. The questions were mostly open-ended. We asked the manufacturers to describe their technology, how it compares to others on the market, applications for their burners, market challenges or barriers, as well as to describe any opportunities for their product that don't currently exist in the marketplace. Part of the survey also included a list of specification data to collect for each burner model. So that consisted of their NOx measurements, carbon monoxide that was available, the BTU range for their models, fuel type, and if at all their burner was compatible with hydrogen or if they were testing hydrogen as a fuel. So based on the literature review and the results at the time, we were able to identify 18 manufacturers and research institutions who we found had ultra-low NOx burner products. We received a 33% response rate for a longer interview or a site visit. Also wanted to note that we attended the AHR Expo in February, and we were able to speak to several burner companies out there as well, some of which later ended up agreeing to a longer interview, and some were not, but we were still able to get some information from them, which we will share as we go through the slides. All right, so for the next handful of slides, I will go over all of the new and emerging ultra-low NOx burners that we have identified from this market study. I've grouped all of these based on the institution or manufacturer. So for each burner, I'll briefly share several details about the technology as well as current and potential applications. At the very end, I'll talk a little bit more about the barriers and the challenges that some manufacturers have had in common that was shared to us during the time of the interviews. So starting off with Lawrence Berkeley National Lab, we had 2 meetings with scientists at LBNL. The first was a preliminary interview followed by a site visit. They have 2 main ultra-low NOx burner offerings, one being the low swirl burner and the ring stabilizer burner. The low swirl burner consists of an open tube fitted with an air swirler. The figure here on the left shows the different sizes of swirlers depending on the application. This technology in particular is known for its high performance and flame stabilization technology using pre-mixed fuel and air for combustion. LBNL had recently collaborated with the CEC to optimize this technology for a boiler application in a wastewater treatment plant. So that really big swirler that you see on the left was one of the prototypes that was developed for that boiler. They have also integrated this burner into a furnace and proved that technology. That application is not commercially available yet. LBNL has also tested this burner in outdoor IR heaters and tankless water heaters, but as of now, the technology has mainly been used for boiler applications. They've also tested this up to 100% hydrogen fuel while still maintaining ultra-low NOx emissions below 9 ppm. So moving on, like the low swirl burner, the ring stabilizer burner has a unique geometry, allowing it to maximize heat transfer. The way that this was described by the scientists at LBNL is that the flame as it being flat, meaning that there's a lot more contact between the flame and the pan, resulting in better heat transfer. They found that this burner was able to increase cooking efficiency by decreasing boiling time for water by roughly 25% compared to using a conventional burner. Regarding applications for this technology, they've applied it to furnaces, ovens, heaters, water heaters, and even in industrial heating applications. Lawrence Berkeley National Lab did conduct some studies on fully integrating this technology into cooktops for residential and commercial use. They found that the revenue margins were not that great and the cost to retrofit their burner would be quite expensive, so they didn't pursue this application further. Since then, they have looked into other applications such as water heaters, but as of the time this interview was conducted, the development of that had stopped due to the pandemic and has not yet resumed to my knowledge. Overall, both burner types are scalable, fuel flexible. Scientists at LBNL have called for further studies to fully optimize them for the specific application. All right, moving on, we interviewed experts from ClearSign. They are a burner R&D company developing burners for commercial and industrial markets. They have a patented technology, which they call the ClearSign Core technology. This consists of air fuel premixing, internal flue gas recirculation, and their patented distill flame holder technology. And to my knowledge, this is the only burner manufacturer out there that uses this unique combination of combustion elements in their fuel burners. ClearSign has 3 ultra-low NOx burner products. First one is their process burner. They have a partnership with Zeeco Incorporated to develop and sell the ClearSign process burner. Applications for this involve heavy refinery fuels up to 80% hydrogen. ClearSign had expressed some interest in looking into other applications using their process burners, such as steam methane reformer heaters and ethylene cracking furnaces. ClearSign also has a boiler burner product. Rogue Combustion is the exclusive partner for selling this boiler burner, and I'll talk a little bit more about this in the next slide. Next is the flare burner, and this is somewhat of a niche product since not many places require ultra low NOx flares except here in California. So flares are essentially a high temperature oxidation process to burn waste gases and are used for burning waste gases in applications like sewage digesters or water treatment plants. And generally, most flares are what is known as a stick flare, which means that there's no stack to contain the flue gas. So there's really no way to measure the NOx emissions in California. But in California, to sort of solve this problem, they have a requirement that all flares need to be enclosed flares, and thus there is an ultra low NOx requirement. As of when we conducted our interview with ClearSign, they have supplied 7 flare burner retrofits in the Central Valley for oil production facilities. ClearSign representatives have also stated interest in developing their product for other applications such as coker heaters, which are also used to deal with heavy crude oil. So as I had mentioned earlier, Rogue Combustion uses the ClearSign technology for a fire tube boiler burner, and this product can be supplied for new boilers or retrofitted into existing boiler equipment. We were able to conduct a site visit to visit their testing facility, and the engineers over there were able to tweak the burner to operate right around 1 ppm NOx and demonstrate its operational flexibility. From my conversations with the engineers, they have expressed interest in exploring other opportunities for optimizing this burner, and as well as looking into water tube boiler applications. The next organization that we interviewed was PowerFlame Incorporated. They have 3 commercially available ultra low NOx burner offerings. The main features of these burner include a pre-mixed firing head in their Ultra C-Max burner and a metallic firing head in their NP2 burner. Regarding the applications, the representatives we spoke to claimed to retrofit boilers with their ultra low NOx burners fairly often and have been pretty successful in doing so. They've also applied their burner to other process heating applications, such as furnaces, bath vaporizers for liquid natural gas conversion, autoclave ovens, and even distillery and brewery facilities. Another company that we spoke to was Vitotherm. Vitotherm is an R&D company based in the Netherlands, and they are working on a new ultra low NOx burner line that is expected to be released by the end of 2023, and this would be their first ultra low NOx burner offering. A unique characteristic besides their burners being ultra low NOx, they also have a 0 carbon monoxide component since they're primarily focused on indoor applications, specifically greenhouses. Their main customers in California so far are the Greenhouse Valley and the Central Market, but they have expressed interest in looking for other partners and applications for their burners here in California. All right, moving on. Honeywell has designed and fabricated the next generation of their Oxytherm burners. This technology uses a patented staged oxygen design, which they claim improves the overall heat transfer and can significantly reduce NOx emissions. This burner runs on close to pure oxygen as opposed to traditional burners, which use air, which is 21% oxygen, 79% nitrogen. So by using this pure oxygen design, Honeywell claims to not lose as much heat to flue gases compared to traditional burners, which use air and end up wasting a significant amount of heat input by heating up the inert nitrogen gas in the air. Honeywell has found that this burner offers fuel savings by up to 25% gas compared to air-fueled ultra-low NOx burners. Regarding applications for this technology, they have designed this burner specifically for higher temperature applications like furnaces. They've successfully applied this to glass furnaces, incinerators, metal melting furnaces, and reheat furnaces. All right, this is another company we were able to connect with at the AHR Expo. They have two ultra low NOx burners, the 2-burner and the inward fired cone IWFC burner. They use a proprietary metal mesh firing cone for their burner system to help with efficiency and NOx. They've applied this technology in a variety of applications, but particularly a lot in the commercial food service industry, including coffee roasters, baking ovens. They've also installed this burner for industrial applications, including furnaces, paint curing, sugar condensing, as well as outdoor IR heating. Next is Cleaver Brooks, and they have an ultra low NOx burner model called the SBR5. Their technology uses a forced draft design, which controls the air and the fuel mixture, resulting in near complete combustion with near zero carbon monoxide emissions. There are a variety of applications that this burner can be used for. They've successfully applied this to boilers, industrial processes, waste heat recovery. They've retrofitted this burner into a hospital for steam usage, laundry, dry cleaning, and as well as refinery and petrochemical applications. All right, CIB Unigas is an Italian burner R&D company that offers ultra-low NOx burners in parts of Europe. But they have very recently installed their first burner in California as of earlier this year. The burner that they recently installed was not an ultra-low NOx burner. However, they are working on developing their ultra-low NOx burner line and are currently in the design phase of that. In a laboratory setting, they have tested their burner up to 100% hydrogen fuel and are using a mix of staged combustion design and flue gas recirculation to achieve the ultra-low NOx levels required here in California. I don't have an exact timeline of when these burners will be commercially available, but they did express interest in expanding into the California marketplace. All right, so the last couple of companies mentioned here, we were not able to get a hold of them for a longer interview or a site visit. So most of this information is purely from research conducted at this point. So Alzada Corporation offers a few ultra-low NOx burners. Their burners utilize a pre-mixed surface-stabilized combustion process that offers uniform heating to operate at very low combustion temperatures. The CSB burner is a metal fiber burner, and the Geotherm burner uses a ceramic fiber specifically used for applications that require a low heat flux and uniform heating. The Alzada NanoStar burner was developed as an ultra-low NOx solution for industrial gas turbine applications specifically. Moving on, Altex Technologies is an R&D company that focuses on combustion systems, and they have developed the next generation ultra-low NOx burner along with support from the CEC, and they call this the near zero NOx burner. This technology is a multi-flame zone burner that integrates a post-combustion NOx reduction process and as well as an in-furnace NOx reduction process, allowing them to achieve emissions under 5 parts per million. In their report, they've also noted that this burner can be commercialized and optimized for boilers, waters, and process heaters. All right, Linde Technologies offers what they call a flameless oxy-fuel burner. They have recently improved their oxy-fuel combustion process to meet the stricter emission standards. So like the Honeywell technology, this product also operates close to 100% oxygen instead of air. They've also tested this burner with hydrogen as well. They are currently planning a field demonstration for this burner using 100% hydrogen fuel in a steel producing furnace. As of when the research was conducted, this field test hasn't happened yet, but I would say stay tuned for that, or reach out to the company for more details going forward. But this is something that they have planned for hopefully later this year. All right, moving on. The Swiss Federal Laboratory for Material Science and Technology have developed what they call the catalytic hydrogen combustion burner. So this process uses a catalytic approach using platinum-coated silicon carbide foams with non-premixing hydrogen and air. So the way that this works is hydrogen is supplied from below and air is sort of blown between the two platinum-coated silicon carbide discs, which leads to a homogeneous air distribution and a uniform catalytic reaction of hydrogen and air. In a lab setting, the scientists were able to perform tests at various hydrogen flow rates, and they were able to achieve ultra-low NOx emissions ranging anywhere between 0.09 to 9 parts per million of NOx. They found that the design of this was safe for cooking appliances due to the catalytic reaction taking place well below room temperature. They have expressed interest in further development for industrial manufacturing for stoves and other commercial cooking appliances, which is currently in progress. We weren't able to get a hold of them for any further updates since when the study was published. All right, the Fives Group is another company that specializes in machinery and processing equipment. They have designed and manufactured what they call the Pillared Nano X Flame Burner, and this uses a unique patented technology to control the flame temperature and improve efficiency. This burner was recognized by the European Union as a best available technique for preventing and minimizing emissions. The main market for this ultra-low NOx burner is primarily in China and Korea. They've applied this burner for both fire tube and water tube boilers. All right, moving on. Johns Inc. Hamworthy Combustion has a few ultra-low NOx burner offerings. Firstly, their Coolstar burner uses their proprietary flue gas entrainment and air and fuel premixing technology to control the flames and achieve low emissions. This burner is mainly suited for larger processes like coker heaters, crude and vacuum heaters, and ammonia and hydrogen reformers. The next burner offering is the Solex burner. This one has the lowest emissions of the three, around 5 ppm, as well as near zero carbon monoxide emissions. The Solex burner uses their patent pending air mix and cool mix combustion process to create a shorter compact flame length, which they claim to be very efficient. Finally, the Rapid Mix burner uses a mix of it's a gaseous injection and mixing system that they use to maximize efficiency and help lower emissions to under 9 parts per million of NOx. This burner is suitable for both new boilers as well as retrofitting into existing units. And they've also applied this for furnaces and dryers. So what I have here is pretty much summarized every model that we talked about. This table is also available on our final report. just sort of breaks down everything that we've gone over with all of the different burners. Probably a little bit easier to follow. You can feel free to download the report and save this table for reference. We've summarized the NOx for each burner, the BTU firing range, as well as a brief description on the technology and the applications. Okay, moving on to hydrogen blending in ultra-low NOx burners. Based on this market study, we identified a number of next generation burners that have been tested with hydrogen and natural gas blends. There's quite a handful of them. I've listed the burner name here as well as the organization and the percentage of hydrogen that they have been tested with. Based on the interviews with the different burner experts that we had earlier, they've called for further testing to include NOx emissions in field trials where hydrogen and natural gas blends are being deployed to better understand the true range of NOx outcomes in higher hydrogen blends. But for the most part, the manufacturers were extremely interested in testing their products with hydrogen. Based on the interviews, there seems to be a lot more interest in using hydrogen gas as a fuel going forward. Okay, so to summarize, we identified a total of 25 ultra-low NOx burner models from this market study. Based on conversations with the manufacturers, they found that most of their burners have been easily able to be retrofitted into existing equipment, such as boilers and furnaces, without having to, change an entire unit or change a lot about the appliance. Most of the burner technologies include some sort of proprietary combustion process to increase efficiency and achieve ultra-low NOx emissions. We found that 11 ultra-low NOx burner models have been tested with hydrogen blends ranging anywhere between 20% to 100% hydrogen. I do want to talk briefly about some of the barriers that the manufacturers have expressed. The first one being regulatory challenges. In particular, what they were mentioning was the San Joaquin Valley Air Quality District has adopted what they call the best available retrofit control technology rule. And this rule states that if businesses achieve lower NOx emissions than originally mandated by the Air Quality District, then all newer permits must meet this achieved in practice limit. So essentially, this rule establishes a moving target for NOx emissions, and businesses aren't able to receive new permits unless they meet the lowest industry standards. And a variety of manufacturers have said that this was a huge hurdle for them, and the moving NOx target has essentially resulted in a loss of income for some of them. Other barriers include brand recognition, especially for those who are newer to the market, or if they have a newer model, they've noticed that people are a little bit reluctant to make the switch without knowing much about the technology. Other barriers include lack of getting permits. And for the case of the foreign burner manufacturers, they've explained that it's been difficult obtaining local representation in California, and there's been some challenges to enter the California marketplace. Project recommendations. Further cost analysis to help quantify the benefits of ultra-low NOx burner retrofits is recommended to further encourage its adoption. The study also recommends further testing of hydrogen blends with ultra-low NOx burners and different equipment. to demonstrate how these burners will perform in older equipment as well as higher percentages of hydrogen as a fuel. The GET program is currently working with one of the manufacturers mentioned to do some emissions and efficiency testing on a ultra low NOx burner as part of a separate project. So I would say stay tuned for that. Yeah, that concludes the presentation. Thank you for listening. And if you have any questions right now, I'm happy to answer them.
I
Looks
have a
like-
question.
Go ahead,
Anushka.
Crystal.
Hi, Crystal.
Hey, this is Crystal. For the ClearSign burner, has it been installed in any wastewater treatment plants in California or in the US at all?
I am not too sure. I can reach out to some of the contacts at ClearSign and get back to you about that. I think I may have seen someone from ClearSign on this call. Not sure if they're still here or would be able to answer that question right now, but if not, I will reach out to them and get back to you.
Okay, great.
We have another question in chat on where this presentation can be downloaded. This will be available on our website soon, and I have to check with Kate, but I think we'll probably be sending it out as well. But definitely check back on the GET website.
And just to reiterate again, the final report with the summary table that essentially summarizes all of these technologies is posted on, you can find it on our website under the completed projects tab if you download the report. There are no other questions. Our next outreach event will be on December 5th at 1 p.m. Pacific time. The topic will be the annual research plan update, and look forward to an invitation on that in the coming weeks. And if you have any questions, feel free to get in touch with us. This is the contact for Brian Maloney. He is our program manager for the GET program. And our LinkedIn handle is right underneath that. Feel free to follow us on there where we post quite frequently with our project updates as well.
Perfect. Thank you, Anushka. I don't see any more questions in chat. So that may have been it. Oh, we have another
see one more
question.
question. I think I saw a hand, but then it went away.
Yeah, I'm wondering if they hit the wrong button. It was close to the emote button, probably.
Thank you.
Yes, thank you, Anushka. Appreciate it.
Yeah, no problem. If anyone has any other questions, feel free to email us. Happy to connect you with the manufacturers if there's any specific questions on their technology.
Perfect. Thank you, Anushka, and thank you for everybody for attending, and be on the lookout for the next invite. Thank you.
Thanks.